The final step is to define a neural network model, and we are going to use a concept called hyperparameter tuning to optimize the model which we've created. So here we're going to split our dataset into 3 training, validation, and testing datasets. The training for the neural network model will be done using the training and validation datasets, and finally we check the performance of the neural network model using the testing dataset. We also perform one-hot encoding on the output columns. Now, this is again required because a neural network model, or any mathematical model for that fact, will not take strings as inputs, and we create and define a simple neural network classification model. This is a sequential model with 3 neurons in the output layer corresponding to 3 activities which we are considering in our project. The activation function has to be a softmax because this is a multi-class classification problem, and softmax function gives a probability for each of the 3 outputs depending on the combination of inputs, and the output or the output classification would be the output neuron with the highest probability. So when we fit the data or train the neural network model and predict it using the testing dataset, we can see that there are a lot of classifications. The diagonal portion of the confusion matrix defines cells which are classified properly. So next we are going to improve the model using hyperparameter tuning, and the ideal case would be to define all the options for each hyperparameter and tune the entire model in a single go. But because of computing resource restraints in our local systems, I have followed a process of tuning each parameter separately. I then fit the model or train the model again. I also looked into learning curves by defining different. So this was a manual effort to optimize the model further. And finally, with the optimized model, we can clearly see that the power of prediction has improved. The number of wrong classifications have come down significantly. Finally, we look at some of the metrics which again can be used to compare the simple neural network model to the optimized one.